In this final lesson for homework packet 3.3, we're going to look at solving radical equations. Equations involving square roots. So here's our first example. We've got 3 times the square root of x plus 15 is equal to 32. We're supposed to solve this and then express our answer as a solution rounded to the nearest hundredth. Okay? Now, the issue with these equations is the variable x that we're solving for is underneath a radical. It's underneath a square root. In order to solve for that x, it can't be under the square root. So the question is, how do we get it out of the square root? So here's how we approach this. We do all the basic stuff that you've done for years first. Subtract 15. Got 3 times the square root of x is equal to 17. Okay? And then we can divide by 3 because it's 3 times the square root of x. So dividing both sides by 3, we end up with the square root of x equals 17 over 3. 17 divided by 3 is 5.67. So we end up with the square root of x equals 5.67. So I don't have x equals, I have the square root of x equals. But just as we did with quadratics, how did we undo a square with a square root? Well, in this case, how are we going to undo a square root? We're going to square it. So the square and the square root undo each other, and I'm left with x. But if I square that left-hand side, I have to square the right-hand side as well. So that right-hand side squared is equal to 32.11. Now, some might be thinking, I remember that when we undid a square with a square root, the other side got a plus and a minus sign. That's true when you undo a square with a square root. However, we're undoing a square root with a square. So we don't need the plus and minus sign. It's just one solution here. So x is equal to 32.11. We've got 2 more examples that we want to take a look at. And what you'll notice about this one is that it's no longer just an x underneath the radical. It's an x minus 9 underneath the radical. Okay? So we cannot deal with the minus 9 until after we deal with the radical, because you have to work from the outside in when solving. So doing the basic stuff that we're used to, subtract 35 from both sides. That's going to be 2 times the square root of x minus 9 is equal to, I believe that's going to be a 37. 72 minus 35 is 37. Now I'm going to divide both sides by 2. I believe that's going to be an 18.5. So that's the square root of x minus 9 is equal to 18.5. It's now at this point, since everything that I have left over is under the square root, I am going to square it. Whatever I do to one side, I have to do to the other. So 18.5 squared leaves me with x minus 9 is equal to x minus 9, because the square root and the square undo each other, is equal to 18.5 squared, which is 342.25. Now, because there was more than just an x under the radical, the square root, I still have more to do to finish solving for x. I need to add 9 to both sides. When I add 9 to both sides, I end up with x is equal to 351.25. So 351.25 is the only value for x here where I can plug that value in and expect this left-hand side to actually equal 72. So we have one more example here, and again there's multiple pieces underneath the radical. I can't deal with those until I undo the radical though. But before I do that, I should probably subtract the 7. 69 minus 7 is 62. So 62 equals 12 times the square root of 2x plus 9. Now I need to divide by 12. So we've got 62 divided by 12 equals 5.167. So 5.16666 repeating, so we'll just round it to 5.167, is equal to the square root of 2x plus 9. Okay. Now the only thing left over here is everything under the radical, so I can undo the square root with a square. That means I have to square this side over here as well. So let's square that side, and I get 26.69 as my 5.167 squared is equal to the square undid the square root, so I'm just left with 2x plus 9. Okay. So lastly, we've got to finish this off solving for x. I'm going to subtract 9 from both sides. That ends up giving me, I believe, 17.69 is equal to 2x. And then I'm going to divide by 2. And I get that x is equal to 8.85. So here's the solution, the only solution that if I plug it in for x, it'll make this right-hand side actually equal 69. Nothing else will. Only this value that we found will make that equation equal to 69.